We will discuss about now smoke ventilation for the warehouses. Okay, as per the local code. If you go to the
Yeah.
local code standards, there is separate code for the smoke venting system using natural vents on roof. Okay, or you can say that by means of mechanical exhaust fans. Okay, there are two system available. Okay, one is the natural and one is the by using the mechanical exhaust fans. Okay, this is basically for the warehouses. Okay,
Okay.
okay. So basically, say for example, you have a warehouses here. Okay, in the warehouse, based on the what type of material you are going to store inside the warehouse. Okay,
Hmm.
so
Hmm.
depends upon that you are going to provide the natural makeup air and you are going to provide with the smoke ventilation. Okay, natural ventilation.
Ventilation.
Okay,
Okay.
so when you talk
Okay.
about natural ventilation, it doesn't mean any fans. Okay, you don't require any of the fans. Okay, so how it works? It works basically based on the wind speed from outside. Okay, say for example, you have a natural makeup air which you have provided the louver, and you will be
Hmm.
providing the natural smoke ventilator. Okay, natural smoke ventilator means if you talk about a picture, uh, uh,
Is that the one which has a fan along with it? Like, and
yeah,
I think I and the fan. It's basically like a small fan, and then the fan. Yeah, and then it will be connected to like a triangular shaped thing, which would basically be your exhaust louvers.
no, it is
Is
not
that
a fan kind of thing. It is actually 1 minute. Let me
yeah?
come. This is for the mechanical exhaust fan. Okay,
Yeah.
this is the natural smoke ventilator. Okay, so natural smoke ventilator is nothing but this particular like a glass kind of thing. Okay, that will open.
Hmm.
So during the fire, when there is a signal from fire alarm, okay, so this particular panel will open. Okay,
Yeah.
so it's just a panel. It's just a closed ventilator, not in fire zone. Okay, like there is a smoke curtain or downstand. It will be protecting the zone wise. Okay, here you heard about smoke close the ventil. It's not a ventilator means it's not a fan kind of thing. Let me search one in
Are
the
you?
Google.
I know there is energy recovery ventilator, but I know that's not what you're talking about. But
Let me search in the
you may need to also tell me what the smoke curtain or a downstand is. Okay. I mean, yeah.
yeah. I will tell you. Yes, yes.
Yeah. Thanks. Thanks.
Yeah. It is basically roof ventilator panel.
If you could just share me your screen with what
Yeah,
you're looking at.
I'm just searching. Uh, yeah, you can see this. Yeah, you can see this kind of thing, right?
Ah, okay.
Okay, so
Okay.
this will open whenever there is a fire. Okay, so this will be linked with the fire alarm system. Whenever there is a
Mm-hmm.
fire, this particular panel will open. Okay,
Okay. Okay.
okay, so that say for example, you can see this particular pictures, right? Okay, you
Yes.
can see this
Yes.
particular picture. So whenever this opens, this will this whatever the smoke inside, it will be taken out by means of natural. Okay,
Naturally, there's no external fan working in this
yeah,
scenario.
yeah, that is why it is called natural ventilation, right?
Naturally. Yeah. Yeah.
Okay,
Understood.
basically this is suitable for where there is a less smoke or less fire expected. Okay, like it is not suitable for where it's a high level storage. Say for example, you are storing some chemicals or fuels. Okay,
Yeah.
so in this type of fire alarm, in this type of materials, you have to go with the mechanical system. But where, say for
Mechanical
example, you are
system.
going to store some, assume that you are going to store some materials like metal parts, okay, where the fire is not
Mm-hmm.
react. Okay, so in that area, you may require like natural ventilation is sufficient. See, because whenever you protect with say for example, you have a some steel material, assume like steel
Yeah.
material. Okay, so when there
Yeah.
is something fire, the fire will not spread, right? Something kind of material. So whenever in that area
Mm-hmm.
you're going to put up fire by means of say for example by using wet sprinkler system. Okay,
Mm-hmm.
you may not expect a lot of smokes, some kind of
Okay.
application. So there you
Mm,
may this
mm.
type of system will work. Okay, like natural ventilation. Whenever there is a door, say for example curtain door, right?
Yeah.
The door will open, so you will get a normal ventilation from outside. Okay, and when you top
Mm,
when you open on the top, your exhaust, whatever
mhm.
the smokes, it can be taken out. Okay, this is for the normal application. Okay, and maybe if you go to here, they may say that. Uh, you can see here smoke ventilation. A smoke vent shall be listed by approved civil defense. Smoke vent shall be dedicated smoke vents with fail safe open. This is normal. Okay, and sufficient makeup air available from the natural vents. Okay, you have to make sure that you are getting proper makeup air fan.
Yep.
Okay, and here they are talking about smoke vents shall be located on the roof. Okay, uh,
Mhm.
okay. Normally they don't use forced system, mechanical ventilation. Okay, it's everything by means of natural. Okay, and you can talk about every 4,000 square meter as considered as a one zone. Okay,
Mm, mm.
okay, and downstand. Downstand is nothing but this. This is called downstand. This will be constructed as a part of the civil. Okay, like a beam kind of thing.
Okay, that is like a partition, or it's
This is
that.
like yeah partition. So when I open my layout, okay, you can also see that in the drawing. Okay, can you see this particular type of warehouse building? You remember you might have
Mhm.
seen that warehouse, right?
Yeah, yeah, steel warehouses. Yeah, yeah,
In the warehouse, can you see this particular beam? When you see the beam,
yeah,
it will be
yeah,
dropped
yeah,
down.
yeah.
Okay, maybe when you see the section, you can see the section uh, something like this, right?
Ah,
You
okay.
can see this
Yes,
is the
yes.
warehouse.
Okay.
So this is the
Mm,
called
mm.
this called like a downstand. Okay. So what is the purpose of
Understand.
the downstand? You can see that why it is required and how it works. Okay. If I go further backwards, okay. Uh, okay. Can you see as a picture here? Okay. You can see that there is a fire in one area. Okay.
Yeah.
And you can see that the smoke spreading towards top of the underneath of the slab, right? And it is
Mm-hmm.
spreading to the some to the nearest area. It spread from all the way to nearest area. Okay, and in that
Okay.
area, by means of radiation, the people get some heat, right?
Yes.
Okay, so to avoid that, what you are going to do, you are going to protect with a downstand. Say, for example, you have a downstand here, right?
Okay.
Okay, so if you provide downstand, the smoke will not spread.
But the smoke will just. But then these are all. I mean, how to put it? For example, when you have a downstand, it will be like it'll be. It's basically a beam, right?
Yeah, it is basically a beam, Faraday beam, you can say.
Yeah,
The
fire
purpose
rated
of
beam.
the
But that
yeah
beam, what's the height of that beam? Typically, your beam would probably be what, like maybe. I've seen beams of maybe 500 mm, 600 mm. Is that
yeah,
max
but
going to be that? Yeah.
But when you see this particular drawing, you can say that as per the requirement, the fire down stand should be approximate like say for example,
1 meter, close to 1 meter.
there is some requirement. Yes, close to 1 meter, something like
Hmm.
that. Okay, down
Hmm.
stand,
Hmm. Hmm.
but that is also given in the code. If I go to the code
Okay,
here,
but then when you have that downstand means, how will the air actually pass through the downstand to the fan?
yeah,
Uh,
that the fan will work. The fan will work, right? The fan will
no,
extract.
sorry, not the fan. Sorry, okay, it's an opening. Sorry, it's not the
Okay,
fan.
opening
Sorry, it's
means
an opening. Yeah.
opening means you have to provide opening in every zone. Okay, say for example, this is the 800 square meter zone, right? Say for example,
Okay.
if you go to my drawing, okay, if you talk
Mm-hmm.
about here, this is one zoning. Assume that one zone will be 800 square meter, right?
Okay, so where is this standard coming from? It's also part of the.
Yeah, this is also part of the this particular code. So when you say here,
Okay.
you can say the mechanical smoke exhaust fan shall be designed to achieve 6 air change per hour in a single smoke zone, not more than 900 square meter.
Okay, 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 okay.
Okay, so when I have a warehouse, okay, maybe you can visit different warehouses. Okay, sorry, let me open. Okay, say for example, I have a warehouse here, right? This is the
Yes.
warehouse. Okay, so it is like
Yes.
lengthy warehouse. Okay, so whenever I design my smoke management system, I will be considering 900 square meter as a one zone. Every 900 square meter.
Mm.
Okay, so in this
Mm-hmm.
particular area, I have to provide one makeup air and I have to provide one exhaust, basically.
Okay.
Okay, so that is why if you see this particular diagram, okay, you can see that this is the warehouse. Okay, in the warehouse you can see that there is one fan, right? Okay, this particular fan, okay, this particular area will be 900 square meter, and then 900 square
Okay.
meter. So 900
So
square
that
meter
900 square meter takes care of both the makeup and the exhaust, correct?
and the exhaust. Yes, yes. Okay, so if
Okay. So that
whenever you
means
talk,
when you're doing your zoning, you will have to zone it in such a way that you have your provisions aligned for both your makeup and your exhaust, basically.
exhaust, yes, yes, yes. Okay, now
Okay.
if you go to the calculation, can you see the
Yeah.
calculation here for the makeup air calculation? Say for example, this is my area, this is my
Yeah.
warehouse, and what is the space area? Total area will be 6219, right?
Yeah.
Total
Yeah.
warehouse. So the
Yeah.
maximum zone sizing area will be 900 square meter.
Yes.
So number of fan will be 6219 divided by 900 will
Divided
give
by
you total number
900.
of fan,
Yes.
right? So
Yes.
this is the way
Yes.
you calculate number of fans. Okay. Then
Mm-hmm.
if you talk about smoke normal area, okay, normal area also you are going to protect with one each zone. Okay.
Sorry, so you said number of fans, right? We don't
Yeah.
have fans, right? These
No,
are all
no. We are,
basically openings,
I'm
right?
discussing about both mechanical and normal. Okay.
Okay, 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 okay.
See, normal means there is no fan. You have only the panel.
Yes.
Okay, see this panel is, can you see here the smoke fan curtain or down stand to create 4000 square meter. Every 4000 square meter you have to provide down stand. Okay, so that is also
Okay.
given in this particular codes. Say for example,
Okay.
if I go to, okay, if I go to this standard, okay, can you
Yeah.
see this one? The floor area exceeding 4000 meter square shall be provided with a smoke curtain or down stand to divide the ceiling space to accommodate a smoke reservoir.
Okay. All right.
Clear, right?
Understood. Understood. Yeah. Yeah. Yeah.
So every 900 square meter you are going to cover, and you are going to cover with 4000 square meter as a one big zone. Okay.
One
So
big zone. Okay.
yeah, that is
Yeah.
the there
But
is a
yeah.
down stand. Yeah,
Yes. So my question is, if you can go back to the drawing that you have shown below, can you come back, please? No, 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 not that drawing, not that drawing. Sorry. The one in the standard. Yeah, can you come now? Yeah. So
yeah,
currently, what am I? The openings that I'm looking at is just basically the ones without the fan, right?
yeah. This is one without the fan. Here you can see the natural
Okay.
smoke ventilator.
Yes, this is the natural. This is the normal situation. Now, for example, when you say we use only mechanical ventilation when we require when we have like hazardous material or something like that. That's where we put in the fans, though. Correct.
Yeah, yeah, yeah.
But then when we put the fans in, will it these roofs will still be the same style, right? Like the
Same,
slanting roofs. Then how
same
do we
style.
do the how would we have the ones with the fans? Can you show me an example of the same? Like the one with the fan, the
Yeah,
same
one with
opening,
the.
but it will have a fan, right? Or is that the case? Or
Okay, that I can show you in my drawing because it is more clear.
yeah, sure, sure. Please, please, yeah. I hope you get where I'm coming from, right?
Yeah,
Because
yeah. If you see, can you see this one?
okay.
This is a roof fan. You might have seen in some of the warehouse.
Yeah, the one which just keeps on running 24/7 sort of a thing. Like it's got like this. I think I've seen this. I think I've seen this. Yeah, it's fine. Yeah,
This is the way you locate. Okay,
yeah,
and
yeah. Okay,
if you go to some of the project, they may request for both intake and exhaust. Okay, for the makeup and exhaust. Okay,
yeah. But that's
okay,
only for
but
smoke condition only that we're talking about, right?
yeah, smoke condition only. This
Yeah,
fan
but
will work only for smoke condition.
yeah, but then your normal ventilation for these warehouse areas, you would be adding like an FHU, and you'll be doing your
Yeah,
ventilation.
yeah, yeah. Normally, this is the condition space, right? Warehouse is the condition space. Okay, so you
Exactly.
have
Yeah.
to provide the air conditioning and also ventilation by means of FHU.
Okay. So you would have like ceiling suspended units, or what would be the generally the case, or you would because I'm sure
No,
you won't be able to have your FHU in the roof for sure.
no, you can keep it on the down, right? Or on the external, right? You can keep it
Outside,
here.
and then okay, you'll pump
Yeah,
the
then
air
you can
upstairs.
come the duct and you can come all the way here and then you can feed it,
Mhm.
right?
But then the thing is, my question is, when you say downstands, is that like that entire space you won't be able to cross any of your ductworks, right? You're having downstands.
Yeah, I understand. So that is why what we will design, say for example, if I go to the layout, what I will do, say for example, I will provide with one FHU here, okay?
Okay.
And this will supply only this area. Then
Okay,
I
so
will go.
okay.
Then I will
I
go with
understood. So
another
you
FHU. Yeah, I will supply here,
you're
right?
basically splitting the FHUs similar to the area that you're trying to cover as
Yeah,
part of the
yeah,
down, maybe
yes,
4,000 meter square. You know
yeah.
that
You can
area at least.
you can design as well. Yes, yes.
Okay. Just to be on the safe side.
Yeah, and
Yeah.
also also for air conditioning, also you can design in the same way. Air conditioning that.
Mm,
Okay, but say for example you are providing down stand. Okay, but still you
yeah.
can cross the duct because it is a warehouse, right? It is a warehouse. So
Yeah.
say for example underneath of the duct I can run my ducting. If I have a space, then you can run also, no problem.
Okay. Yeah, but generally, yeah, warehouses are more like, they're not like your typical 5 meters. They're probably like 10 to 12 meters high, right? Bit
Yeah,
thick.
yeah, yeah. Yes,
So,
yes.
I mean,
You
there should
can.
be a lot of space to run our
Yeah, you
compressors and
can see
everything,
here it is
right?
a 9.4 meter, right? You can see the text.
Mm-hmm.
Say for example
Mm-hmm.
9.4 meter. Okay,
Okay. So even if you ask for a void of maybe 1 meter also, you could run your services like
I
all the
can
way
run.
across.
Yeah, we
You
can
can
run.
run.
We
Okay.
can run. Okay,
Understood.
okay. So here
Mm-hmm.
we will talk about uh, like say for example mechanical exhaust fan. Okay, so here
Yeah.
you talk about here the smoke exhaust fan rated for 400 degrees Celsius for 2 hours, right?
Yeah.
Okay, the temperature 400 degrees Celsius for 2 hours.
For 2 hours. Yes. 400 Celsius.
Okay,
Yeah. Okay.
and
Yeah. This is the
you can
specification bit that we were talking
yeah,
about,
yeah,
right? Oh,
yes.
understood. Yeah.
And when you talk about mechanical smoke exhaust fans, shall be designed to achieve 6 RPM per hour in a single
Okay.
smoke, not more than 900 square meter, right?
So that means, yeah, okay. So this is where the so this is the scenario only in warehouses where we actually use 6 air changes per hour. That
Yeah,
too with an area restriction of no more than 900 meters square.
900 square meters. So when you go in this my calculation sheet, you can able to see here, right? Like if you go here, the makeup air calculation is for total area. Then you have a area reference. Then you have a space area, maximum zone, number of fan you can calculate. Then you will get the total volume. Like you have a area and height. Then you can get the air change six air change per hour for the fire
Yeah.
mode. Then you will get the total exhaust fan, right? Then you are going to
Yes.
calculate the fresh air fan by multiply by 85% basically, right?
Yes.
Okay, so the fresh air fan for the warehouse, okay, you can go with the mechanical exhaust makeup air fan. Or also, you can check is there any fresh air available through some resource. Okay, nearest. Say for example, this is the you have air curtain, right? Sorry, you can
Mhm.
say roller shutter. If you talk
Yeah.
about warehouse, you have a roller shutter in front, right?
Yes. The one which you
Okay,
open and close with a lot of force. Yeah, I understand. Yeah.
okay. Say for example, if you see this section, you can see that this is the warehouse. Okay, you can see the roller shutter, right?
This is
Okay, so
basically the front view, right? Where you
yeah,
have the yeah.
you can say the front view. Yeah, front view of the warehouse. Okay. So during the
Yeah.
fire, what will happen? The warehouse, the shutter will open because you have interfaced with the fire alarm system. So whenever there is a fire,
Mm.
this will open automatically.
Okay.
Okay. So when it opens, your fresh air will be draw from the roller shutter, right? So then
But then
your
you will have to still cross verify how many shutters you have, and then you have to see if
yeah,
that equates to
yes,
your
yeah,
makeup pair that you're trying to achieve.
yes. So
At
that is
least, if for example, if looking at this, the total makeup pair required is say 816 liters per second. You would divide it by the number of what do you call it?
yes,
Number of roller shutters you have, and you basically try to see if it is more or less.
of
And
course, yes.
if it is less, you might have to supplement with an external mechanical fan
External, yeah.
easily.
See, for this case, you require fresh air of so and so 82.8 meter cube per second, right?
Yeah.
Okay. And if you see the velocity, like how much air will be coming from outside, normally 3.6 meter per second as a wind speed, right? Okay.
Okay,
So now opening, how
3.6
much it is
meters,
required? Opening area required. Say for example, based on this
23 square
velocity,
meters.
you can require
Mm.
23 square meter. But what is the roller
Yeah,
shutter area? Each roller shutter having 5 meter by 3.5 meter. Okay.
yeah,
And
yeah.
how much total shutter? 7 numbers. So total
7 numbers. Yeah.
17.5 square meter available. So 17.5 into 7 numbers, total 122.5.
Yeah.
Okay, so which is greater than
Okay.
24.6 square meter. Like
Okay. So it is not necessary that it has to be like you have to split it zone wise for make a pair though. It's not necessary. Only
yeah,
the
makeup.
exhaust we are splitting zone wise, like
Yeah, because
area.
makeup air it is open, right? Everywhere it will
Yes.
be
Yeah.
because you have a
Correct.
seven doors. See number of fans, 7 fan. Okay,
Yeah.
and also you can see that 7 number roller shutter approximately.
roller
Okay,
shutter doors and stuff.
so
Yes.
it can give makeup to all the area, right?
Understood. Yes.
Okay,
Yes.
and the exhaust fan calculation also the same way, like a space area, maximum zone, number of fan, area, height, number of air change per hour. You can calculate 6 air change per hour, right? And the makeup area
Yeah.
will be 85 percentage
Yes.
as per the code. And if you go to the as per the local code, you are going to enter by using their standard format. What is the area? What is the height? What is the total airflow rate? If you consider 6 per hour, make up here 85 percentage. So you will get all the parameters here, right?
Yeah. Yeah. Understood. Yes.
Okay, so this is the way to calculate for the smoke ventilation system. So if you go to the smoke ventilation system, you can see there is a warehouses, okay, and you can see that this is all incoming through the roller
Roller
shutter,
shutter.
okay, and you are going to design the fan for every 900 square meter, okay, and the maximum
Yeah.
zone will be 4000 square meter, where you going to provide with the down stand. Say
The
for example,
downstands. Yes.
yeah, so say for example, if you see the down stand, it will be in somewhere here. Can you see the down stand here? Because this will be
Mm.
off of the portion and this will be off of the portion. So in center you
Can
have a
you
down
show me
stand.
like a 3D image if you have it like anywhere? Because I mean I've understood it, but at the same time, it
The
will
down
be through
stand,
the entire. Yeah, okay, that's the end. So the down stand would be there the
yeah,
entire
a down stand.
warehouse
You
basically,
no,
right?
you can see here, right? Down stand. See that? Can you see this white
Okay, so
color?
that yeah that okay that white color will be there in every 4,000 meters basically.
Every
Like
4000 square meter. Yes, yes.
it'll be, but it's not like but yeah my doubt was the thickness of that entire down stand, how that would be the thick, it'll be how thick
Uh,
would it be. Do you get where I'm coming from? Because each of these the down stand, you're not going to have just like one this thing, right? It will be at least like I'm not sure if it's there in the
yeah, yeah.
standard.
You mean the thickness of the material is not given in the
Exactly, yeah, yeah.
in our
So
code.
that
It is
yeah
not
so that thickness of the material will be covered in the specifications basically, right?
specification. Is not our specification. It is part of architectural specification. It's not a
Architectural
mechanical item,
specification.
right?
Okay, that's why I wanted to know. But we have if the I mean architects won't be missing it, but if it's not it's if it needs to be picked up, it has to be told by us though,
Yeah, yeah, yeah.
right?
Because we yeah, yeah, because it is our requirement, right? Basically, they are complying, but it's basically our requirement, right? Smoke management
Understood.
requirement. So
Understood. Yeah.
whenever you are with as a consultant, we should check everything, right? Whether
Mm-hmm.
architectural is complying as per our requirement. Even you check
Yeah.
with the electrical people whether they comply, whatever the power we given, whether they comply or not, right?
Yeah. Yeah.
So that is our
Understood.
part of coordination, but we have to check that. Yes.
Understood. Yes. Yes.
Okay. So I think this is clear, right? The smoke
I think to
management
a certain extent, yes. Yes.
for the
Yes. Yes.
warehouses. Okay. I will share
Yes.
with you one of the drawing, one of the project which I have worked for. Okay. You can also
Yeah.
calculate, and also they check the wind effect. Okay, based on the buoyancy stack effect. Okay. This is also there is a as per Ashray, I guess. Okay. So you will enter the floor area, height. Okay, natural opening available, and there is a wind
Mhm.
effect. Okay. There is an equation called wind 0.05 multiplied by A multiplied by V. Okay, and you're going to check the
Okay.
wind effect, how much wind velocity, so how much wind
Mhm.
you're going to get, okay, by means of from outside, by means of wind effect.
Okay.
Okay,
You mean
then
naturally, right? Or
yeah, naturally how much air is coming
okay,
from
this is the
outside.
scenario where we have no fans but normal natural ventilation, right?
Yeah, natural, no, the natural air opening, yes. Say for
Natural
example,
air openings. Yes, yes. Like
yeah,
for
yeah,
example, the one you have like lower level makeup air openings, and then you have the high level just normal openings which get
yeah,
into the fire
yeah,
alarm.
yeah.
That's the one you're talking about, right?
There also they calculate, and for the forced ventilation also we have calculated, just to make
Yeah,
sure
forced
that
ventilation, I've understood. That is where we have the fans and the high level for the
yeah, yeah,
exhaust and
yeah.
everything. But in this
Natural
case, it's only
ventilation you can
openings.
calculate. Yeah, you can calculate by means of this equation.
Yeah,
Okay,
but then
so
you say, for example, so 0.05 into area, that is in me. Okay, that's in me. When you mean area, that's the area of the makeup louver that we have or makeup
the roller shutter
openings that
area,
we have.
yeah, openings we have. Yes, you can see that
Yeah.
the floor area, the height of the
Mhm.
door like 9.5 natural openings. Okay, the floor area height natural openings. Okay,
Yeah.
so this is the total required flow. Say for example, 89,610 is the required flow.
89,000. Yeah, that's your required flow. Yes, but then how did you come across the law? Sorry, I'm just getting. So just give me a second. Yeah, let me just have a look through it because it's 0.05 into area into velocity. Meter cube. V is the meter per second. So
let me open this Excel sheet.
okay.
Sorry. Yeah. Can you see here? This is the area. You can see that C6 is the area, then C7 is the
Yeah.
height, right?
Yes. Yeah.
Then number of air change, I guess 6 air change per hour, multiplied by 0.895, 0.85, it's a makeup here, right?
Yes.
Okay.
Okay. Okay. This is the makeup pair you're trying to calculate. Huh? Okay.
Yeah, okay.
Sorry.
And yeah,
I no. But this wind effect formula, right? That
yeah, this is the required flow. How much you flow, you require
Okay.
to
Oh,
make up a
sorry,
flow.
sorry. I
Then
think, okay, sorry, my mistake. I think I made a mistake. I thought it was based on the wind effect formula you're trying to calculate. This is the
no, no,
same,
no,
this is
no.
the
First, you are
same
going to
6 air
calculate.
changes per hour you're trying to
Yeah,
calculate, right?
yeah.
Yeah.
What is the required airflow? Okay. Then, based on the wind effect, this is the equation. If you go to NFP 92, you will find this equation. Q wind is nothing but 0.05 multiplied by area multiplied by V. So when you enter here, 0.05 multiplied by A, C8 is the natural openings through the uh, roller shutter. Okay, and
Yeah.
multiply by 1.4, which is the velocity, the lowest velocity. Okay, if you go
Okay.
to this one, if you go to Dubai condition, Abu Dhabi condition, you will find what is the velocity here, 1.4 meter per second velocity. Okay, so you are applying with that velocity, you will get the wind speed. By means of wind, you are getting this much airflow rate.
Okay. So
Okay,
naturally, this much air would be possible only. That's
yeah,
the
yeah,
idea, right?
yeah, and there is a buoyancy stack. There is another one is available. Okay, so buoyancy stack
Okay.
equation is Q stack equal CD multiplied by area multiplied by square root of 2GH in the bracket T outside by T inside. Okay, divide by T outside.
Okay.
Okay, so now if you apply this equation, CD is nothing but 0.65 and gravitational force is 9.81. Free area
Yes.
is the free area opening, right?
Yeah.
And H is the height, and average outside air and average inside air, which is like what is outside air and what is the inside air temperature difference. Okay, so if you calculate here, you are going to calculate like 0.65. Okay, multiply by area you can calculate like C8, this is the area, right? Natural
Yes.
air openings, then square root of 2 multiply by 9.81 multiply by the height C9 is vertical distance 9.5. Okay,
Yeah.
and multiply by, this is in Kelvin basically. Okay, like 318.6, which is ambient temperature minus internal temperature. Okay,
Understood. Yes.
so based on this equation you will get total airflow rate by means of stack. Okay, so
Yeah, but
available
these are
total
all
flow,
makeup. But these Qs that we are these Q that we are asking is all makeup air
makeup,
basically, right?
available makeup. See, what is the required
Available makeup.
makeup? This is a required
Yeah.
makeup. Okay, and what is available makeup? 193.552 by means of stack and by
Yeah.
means of wind 8575. So when you add
Okay.
together, you are getting 202,127.4, right? Okay, clear,
Which
right?
is more than what is required.
Yeah, yeah. So what is the minimum required area is only 54.3. What is available? It is 122.5, right?
2.5. Okay, so that you just do it based on sorry, can you, how do you calculate the area of that? You've got the winds, yes.
No,
Um,
this area, right?
yeah, that area.
See here.
Okay, you just do the reverse calc or
No, this is the liter per second, right?
yes.
Okay, divide by, if you divide by velocity, you will get say for example a minimum required area based on this
Oh, you
particular.
mean so whatever? Okay, so basically whatever liters per second, you basically convert that to meter cube per second, and then you use
Then
the
velocity you will get how much minimum required flow.
meter square. Sorry, but that's still meter per second, right? We will need meter square.
Yeah,
Yeah,
divide by velocity.
Sorry,
Velocity.
yeah, but divide by. Sorry, it's my mistake. Yeah, we
Okay,
yeah,
so
divide by
that is the way
velocity
you
to get
calculate minimum required area. Okay, so
area.
you are going to
Understood.
check whether natural air opening is available or not, is
Yeah.
sufficient or not
So
sufficient.
the velocity in this case you have taken is still 1.4, right?
Yeah, 1.4. Yes, you can also find here. Yes, this is 1.4. 1.4 is the velocity.
Okay.
Clear, right?
Okay. Yeah. But this velocities that you've taken, I've never come across that velocity bit, that 1.4 or one that
No,
you're
no,
saying, right?
no, no. This will change. It depends upon your location. Say, for example, if you go to ASHRAE, okay, uh, can you see the velocity here? This is a velocity for that region, 1.4.
Okay.
Can you see here? Mean coincident wind speed, 1.4.
Okay. I've never never noticed it, So yeah,
Yeah,
thanks.
and say, for
Interesting.
example, if you are going for, say, assume that you are going for some other country, okay. So then what you
Yeah.
will do? Assume that this is the, say, for example, Dubai, okay. So when you do the
It will be
calculation,
different.
you will do
Mm.
calculation based on 2.2, right?
2.2. Okay. 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 Okay.
So
Okay.
what is the
I
wind
understood.
available in that region?
Mean coincident mistake. What is the next one? PCWD. That's the
This is
P.
the direction of the wind.
Okay.
So when the wind directed towards 0 degree, that
Towards
means north. Okay.
north side.
So this is 180 degree. So
This
you
is
can
more south
correlate
side.
like,
Yeah. Okay.
yeah, 0 north, 90 is the east. Okay. Then
Yeah.
180
So
will
this thing
be
would be
south.
south, basically.
South. Yeah, basically south. Yes. So this
Mm.
is the wind direction is a wind speed will be south direction, right?
Okay.
So
But
this
we don't
also,
use any of, but we don't use these velocities anywhere else. Like it's only in the case of these natural opening scenario, or
see, basically I will tell you where they use it. Okay. Say, for
yeah,
example, you have a building. Okay. Assume that you
yeah,
have a lot of generators outside the building.
yes, yeah,
Okay. So remember the generator exhaust, like it will discharge fumes, right?
yes.
Okay. So due to this wind, direct wind, based on the natural wind from the earth surface or from the local area,
Mm,
what will happen? That fume may direct towards your building. Suppose, for example. So what
mm.
will happen? That fumes will come into your building and that will affect your comfortable, right?
Yes, yes.
So what they will
Okay.
do, they will such a way that they will locate the generator room where the fume will be discharged to outside. Okay, like not to the
Mm-hmm.
towards the building. So that is the way they decide. That is based on, normally you heard about CFD analysis and all,
Yeah, yeah, yeah. I've heard of
because
this.
that
Yes.
fumes will be very high temperature that may affect to the nearest
Mm.
chiller plant room. Okay, where
Okay.
so that study they will do based on this particular values.
Mm, 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 mm.
Clear it. For
Okay,
that they will use
okay,
it. Okay,
okay.
and also for this particular natural, for Varos, why we are using, because we are checking whether how much natural ventilation is available from the outside.
Understood. Yes.
So that is why we are going to check in this equation basically, right?
Got it. Got it. Yes, yes. Understood. I think I follow.
Okay, so
Yes.
this is the calculation for the warehouses. So simple calculation. It's not complicated. When you go through the code, you can able to understand how to calculate smoke ventilation for the warehouse, right?
Yes, yes, yes.
Okay, I will be sharing this all Excel sheet. You can
Sure.
practice. Okay.
Sure, sure. Thank you so much.